In the last session, we were talking about drawing atoms. In this session, we're going to talk about atoms versus ions. This one can be a little bit confusing, and so you may have to watch this video segment a couple of times, but I'm going to do this as easy as I know possible. Reminder, still need to have that periodic table because we're going to use that periodic table a lot in this section. With something very simple. Let's start with sodium, just as a review. Sodium is element number 11. So when you have 11, that means you're going to have 11 protons and 11 electrons because you're neutral. Now, again, we know there are neutrons there, but we're just going to ignore them for right now. It'll make life a little easier for what we're doing here. Sodium has 11 electrons. That would be 1, 2 in the first ring, 8 in the second ring, 3, 4, 5, 6, 7, 8. 8 and 2 is 10. And one more is 11. Now I'm going to take this one and compare it to another element, chlorine, element 17. 17 protons, 17 electrons, neutral. Now you may wonder, okay, why does he keep doing the math? It's going to be very important here in just a second. Now I'm going to make this one, I'll just keep it the same color, completely different elements. 2 electrons in the first, 8 in the second. And they may think, okay, this is a review. It is. We're going to do something different with it. 1, 2, 3, 4, 5, 6, 7, 8. 8 and 2 is 10. That gives me 7 more. 1, 2, 3, 4, 5, 6, 7. That's what they look like. This is what we did in the last session. Here's what a sodium atom looks like when we draw it. Remember, atoms don't look like this. This is how we draw them on paper so that we understand them. Same thing is true here. This is a chlorine atom. They're different from each other. How do I know? Well, 11 protons, 17 protons. Every element has different protons, but this is how we draw them. Now, here is where it is different. So far, we've drawn atoms. This is correct, and this is correct from the last session. Exactly right. Now, here's the easiest way I know to explain what ions are. Atoms look like this and this, but they don't like to look like that. Atoms want to look like you and I on Thanksgiving Day. You see, when we have Thanksgiving, we have lots and lots of food. We are completely full. We want to be full of electrons. It's actually what is called the Octet Rule in chemistry. It's having full outside ring, R-I-N-G, of electrons. Want to have a full outside ring of electrons. They want to be full. Now let's check. First ring's full, 2. Second ring's full, 8. Third ring only has 1. That's not full. First ring has 2. That's full. Second ring has 8. That's full. Third ring has 1, 2, 3, 4, 5, 6, 7. Oh, he's so close. But he's not full either. Atoms, this is correct. This is correct. So you have to watch your words. If it says atom, this is right and this is right. But atoms don't like to be like that. They want to be full. So how do atoms do that? Well, here's how they do it. Let's talk about sodium here for a second. How could he be full? Well, if there's 1 in the outside ring, 2, 3, 4, 5, 6, 7. There's 7 empty boxes or 7 empty spaces. There aren't actually boxes in an atom. There's 7 empty spaces here. If he could somehow find 7, he would be full. Check this guy. 1, 2, 3, 4, 5, 6, 7. This guy only has 1 empty space. Let's see what they can do. Well, let's go back to sodium. Here's what happens. There's 2 choices every time. 2 choices. Here are the choices. Choice number 1. He could gain 7 electrons, and he would be full. Or, let's say he threw away 1 electron. Now, I'm going to let that electron freeze right there. Just let it just freeze right there. Now, how do I know what to do? Well, I have to look at this. Take in 7 or getting 1, which sounds easier. Excuse me. Taking in 7, 1, 2, 3, 4, 5, 6, 7, or giving away 1. To me, it sounds a lot easier if he gives away 1. If I'm correct, if he gives away 1, there's nothing in the outside ring anymore. If I erase very carefully here, you'll notice inside ring has 2. Outside ring has 1, 2, 3, 4, 5, 6, 7, 8. Is he full? He is full. He is happy. That's exactly what he wants. Now, again, I'm going to have this electron. It's just freezing right there for a second. But here's the most important thing. This guy still has 11 protons. How do I know? I didn't touch the nucleus right there in the middle. But now he has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. He lost one. 11 protons, 10 electrons. 11 pluses, 10 minuses. He now has a plus 1 charge. Let me do that math again. 11 pluses, 10 minuses. He has one more plus. He now has a charge. He looks like a magnet. So Na has a plus 1 charge. Is he okay with that? Yes, because he's full. That's what he wants, is to be full. Let's look at the chlorine over here. Chlorine has 1, 2, 3, 4, 5, 6, 7 in the outside ring. So he has 2 choices as well. Again, 2 choices. Choice 1, get 1 electron and be full. Choice 2, give away 7 to be full. To me, it sounds easier if he gets 1 from somebody. And let's just put that electron inside that box. He's now full. That is what he wants. He wants to be full. He's happy now. But this guy has 17 protons and now has 18 electrons. He gained 1. 17 pluses, 18 minuses. He became -1. This and this is what is called an ion. I'm about to give you a definition, so make sure you write this down. An ion is an atom with a charge. An atom with a charge. Why did he now have a charge? Because he was trying to be full. And when he's trying to be full, he chooses to move electrons. He either throws away electrons or gains electrons to be full, whichever is easiest. Now, what I want to do here for a minute is I want to show you a couple more just to make sure we got it. Then we're going to do something with those guys. We'll do this one just a little bit faster, not near as slow. Let's take something like nitrogen. Nitrogen is element 7. 2 in the first, 5 in the outside. 1, 2, 3, 4, 5. And let's also take somebody like magnesium, which is element number 12. 2 in the first, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10. He needs 2 more. 1, 2. This process isn't very difficult. Let's count. How many does this guy have in his outside ring? 1, 2, 3, 4, 5. Is he full? No. He has 3 empty spaces. This guy has 2 in his outside ring, so he has got 6 empty spaces. 1, 2, 3, 4, 5, 6. You have a choice to be full. What are you going to do? Well, in this case, 1, 2, 3, 4, 5. Is it easier to give away 5 or take in 3? The easiest thing to do is to take in 3 electrons. Now, you may be thinking, where does he get them? Don't worry, I'm going to fix that question here in the next session, but we just want to see how they make ions. We're going to talk about where they get them here in just a minute. So getting 3 electrons from someone else would be how he's going to fix himself. So he now has 7 protons and 10 electrons. How did I get 10? 2 here, 1, 2, 3, 4, 5, and gain 6, 7, and 8. 8 and 2 is 10. He becomes -3 charge. So nitrogen becomes -3. You'll notice the symbol, and up high in a superscript, -3, gaining 3 electrons. What does this guy do? 2 electrons and 1, 2, 3, 4, 5, 6. This guy, giving away 2 or gaining 6, it sounds easier if he gives away 2. If he does that, that whole ring disappears. It's gone. and now he's full. So he now has 12 protons, because I didn't touch his nucleus right there, couldn't get there. Now he has 10 electrons. 12 pluses, 10 minuses, plus 2 charge. Mg becomes a plus 2 charge. These are what are called ions. The only difference between them is this: you draw atoms and ions the same way. Atoms look exactly like they do on the chart. Equal number of protons and electrons. When they move their electrons to be full, that is what's called an ion. In the next section, I'm going to give you a couple of atoms and see if you can convert them into ions yourself.